So here's the current list of assignments. So P6 was due last night, so I'll get that graded for you this afternoon, and I will post solutions along with that, and I'll send you an email to when that's done. Um, 7, 8, 1.1, 1.2. WebAssign assignments are here, and we're going to have the first exam on. Oh, this one was due last night. Sorry, so that one's gone. So we just have these two. And the first exam coming up on Wednesday next week. Okay, on these sections. It's going at a fast pace. That's because the summer class is compressed. Normally what is 14 weeks, we're trying to do it in 12. So, things get pressed together. Plus, we don't have a final exam time. So it's got to move a little bit, and we're missing a couple days due to holidays. Okay. So moving along on to section 1.1. So the coordinate plane So the two-dimensional coordinate plane is defined by two real number lines meeting at a 90-degree angle, i.e. they're perpendicular. Meeting at a 90-degree angle, at coordinate 0 in each. So you've got these two real number lines, and typically it's called the x-axis and the y-axis. And these are two lines, a horizontal and a vertical, which meet at the 0 in each. So you've got the numbers 1, 2, 3, 4, 5 on the horizontal axis. As increasing to the right, as was talked about before. And on the y-axis, it's increasing in the upward direction. So 1, 2, 3, 4, and decreasing in the downward direction. -1, -2, -3, -4. You can skip these arrows when you're when you're drawing this. It's clear that you're talking about infinite lines, and it's better not to clutter up your drawing with unnecessary items. Now, every point in this plane has a unique x and y coordinate that goes along with it. It is identified by a unique pair of numbers x comma y. Right? So, for example, here's a bunch of points. So if we say the point 3, 1, right, x equal to 3, y equal to 1, right, you take the 3 on the x-axis, the 1 on the y-axis, and then you draw this rectangle with the x and y axes as two of the sides, and then the other two sides copied like that, and then this is the point 3, 1. This is the point 1, 3, x equal to 1, y equal to 3. This point right here, well, the x coordinate and the y coordinate, or sorry, the x coordinate is 0, and the y coordinate is negative 3. This point right here, right, the x coordinate is minus 2.5, or minus 5 halves, y coordinate 0. Right, I mean, you don't just have integer pairs, you got all the different kinds of pairs. Right here, negative 2, or sorry, x equal to 2, y equal to negative 2, so on and so forth. I mean, you've probably seen this before, but, you know, just to talk about it again so we make sure that we're all on the same page with what we're talking about. So now the distance in the plane, okay, are calculated, sorry, I shouldn't say distances, the straight line distance between 2 points in the plane is measured using the Pythagorean theorem. Although in this context it is usually called the distance formula. Not sure why it's got a different name in this context, but it does. So remember, on a straight line, on one axis, okay, distances are just measured by subtraction. And absolute value. So like here's point A, here's point B, and this is the distance between them. So this is B minus A. Absolute value, because you know you want to take the positive value here. So absolute value B minus A. Right, and right. Remember, the difference between A minus B and B minus A is that they're negatives of each other, right? Like 3 minus 5 is negative 2, 5 minus 3 is 2. But when you're talking about distance, you always want the positive value, so you stick the absolute value sign around it. So in 2 dimensions, if 2 points don't have, if the straight line between 2 points don't lie on a horizontal or vertical line, then we get the following picture. Of a right triangle. So here's a point. So we'll call this point AC. And here's another point over here, and we'll call this point BD. Okay, so x coordinates A and B, y coordinates C and D. Now, if you take a horizontal and a vertical line through the AC and the BD points, right, that meet at a 90-degree angle, like that, then this point right here has x coordinate equal to B and y coordinate equal to C. Right? Because they lie on the same horizontal line here, okay, the y coordinates are the same, just the x coordinates change. And because these 2 points lie on a common vertical line, the x coordinates are the same and the y coordinates change. So the distance from here to here is the difference in the x coordinates. So this is B minus A. And this distance along the vertical line is D minus C, an absolute value. And then this is the distance between these 2 points here, the straight line distance. And that is what we want to calculate. So this distance, D, well, since we have a right triangle, we've got the Pythagorean theorem. That this length squared plus this length squared is this length squared. So D squared is equal to B minus A, absolute value, squared, plus D minus C, absolute value, squared. But then, we want a formula for D, right? So this is by the Pythagorean theorem. So by the Pythagorean theorem, we get this, but since we want an expression for D rather than D squared, which we rewrite like this. D is equal to square root of. Now, there's no need for absolute values because when you square something, if it was negative, it'll become positive, that quantity. Right, so there's no need to leave the absolute values here in that. So the distance is right here. So that's the distance formula, which, as you can see, is just the Pythagorean theorem, just rewritten a little bit. Oftentimes, the distance formula is thought of like this. So intuitively, distance is equal to the square root of the change in x coordinates squared change or difference of x coordinates squared plus the difference of y coordinates. All right, so that gives a little bit more of an intuitive feel there. Okay, so distance is the difference in the x coordinates squared plus the difference in the y coordinates squared, square root of that. So, for example, here's a few points in the plane. Let's say 1, 2, and 1, 2, 3, 1, 2, 3, 4, 5. You know, by the way, when you are drawing points in the plane, okay, unless, I mean, it's really important to be like super accurate with the coordinates. You don't have to like, take your ruler and tick off these points and label them 1, 2, 3, 4, 5. I mean, unless it's important for the graph to look a certain way. Here, it just isn't. Let's try another one over here. -1, 3. I guess that would be more like here. So let's find this distance, and that distance. So we'll call this distance A, call this distance B, and call this distance C. Okay? So the distance A is equal to the square root of, all right, the difference in the x coordinates. So here the x coordinates are -1 and 1. So you take the difference of -1 and 1. Now it doesn't matter in which order you do it. Okay, because you're squaring things, and the only difference if you did this point minus that point or that point minus this point is they're negatives of each other, but that goes away when you square it. So it's -1 minus 1 squared plus the difference in the y coordinates, 3 minus 2 squared. So that distance A is, this is 2, so -2 squared plus 1 squared. So that's square root of 5. The distance B. Okay, the distance B, okay, the difference in the x coordinates, so 3 minus 1 squared plus the difference in the y coordinates, 5 minus 2 squared, right, is equal to, so this is 2 squared plus 3 squared. So 4 plus 9 is square root 13. And the distance C, okay, difference in the x coordinates. Now, when you've got a negative coordinate and you subtract, like, be careful how you do that, because when you subtract a negative, you end up adding, right? So it's 3 minus -1. Uh, 5 minus 3. Right, so this is going to be 3 plus 1. So that's 4 squared plus 2 squared. So that is 16 plus 4, square root 20. By the way, look at that triangle I just drew there. Is that triangle another right triangle? So, I mean, I've got these three distances. Let's copy them over and onto the picture here.
Is that how you want the final answers, or do we solve that final square root?
Well, I mean, why would you? I mean, so square root of 5, you stick it in your calculator and you get some number. Um, Unless you're going to do something with that number, it's not necessary. Like, this is an exact answer, right? When I say square root of 5, that number, when you square it, is 5. If you put it into your calculator, then you're going to get 2 point something something, 2.2 something. But that's going to be an estimate. So in some sense, this is the better answer, right? But if you need an actual number to like look at and use for something, then you put it in the calculator. So the answer is, unless you're going to do anything more with it, no. Or if you like using the calculator and want to do it, go ahead. It's fine. Doesn't really matter. So this is, these distances are, let's put them in there. So A was square root of 5. B was square root of 13. And this is square root of 20. Notice, okay, the square root of 20 squared is not equal to, this means not equal, right? So this is equal, this is not equal. The square root of 5 squared plus the square root of 13 squared, right? Because 20 is not equal to 5 plus 13, because 20 is not equal to 18. This tells us that that triangle there is not a right triangle. Formed by these 3 points is not a right triangle. Right. The Pythagorean theorem it tells us that with a right triangle, right, like a squared plus b squared equals c squared. But another like extension of the Pythagorean theorem is called the law of cosines, which you'll look at in your pre-calculus class. It tells us that if a squared plus b squared is not equal to c squared, then it's not a right triangle. Or if it was, then it is a right triangle. So let me write that down, what I just said. All right, so given this, all right, that's a, that's b, that's c. C squared equals a squared plus b squared. Also, if given some triangle, which you don't know if it's a right triangle or not, A, B, C, well, I guess that's the longest side. Given a triangle like that, if it happens to be the case that c squared equals a squared plus b squared, then the triangle is a right triangle. Must be a right triangle. So this would have been a 90-degree angle, but I mean, you might not know it. I mean, when you draw something, I mean, whether or not it's perfectly square, you kind of can't tell sometimes. Like instead of 90 degrees, it might be 88 degrees or something like that. So it's hard to tell the difference. Unless you get out your speed square and check it, then you know for sure. Go back to the carpentry analogies. Okay, so that's just a fact. Comes up once in a while. With a right triangle, this leg squared plus this leg squared is equal to hypotenuse squared. But given any triangle, if it does satisfy this, then it must be a right triangle. And this is actually the law of cosines. So this is part of the law of cosines, which you might not know, or you might know. But if you take the next course in the sequence here, you'll run into that. It's pretty cool, the law of cosines. All right, midpoints. Given a line segment between 2 points A and B, A, C, and B, D, the midpoint of the line segment is calculated as follows. So here's your AB or AC. Here's your BD. And there's the line between them, like that. So the middle center of that line segment, well, it's got a real easy way to calculate it. You just take the average of the x-coordinates. So A and B are the x-coordinates here, and the average is just their sum divided by 2. And the average of the y-coordinates is the y-coordinate of the midpoint. So this is C plus D over 2. So finding that middle point is really quite easy. So for example, so find the midpoint of the segment from 1, 2 to 4, -4. Alright, so I've got my 4, -4, it's going to be down here. And I've got my 1, 2, it's up here. And there's the segment between them. So that midpoint is right there. Well, you take the x-coordinates, 1 plus 4, and divide by 2. Y-coordinates, 2 minus 4, divide by 2. So this is equal to 5/2, comma, minus 2 over 2, minus 1. So there's the middle of that line segment. Okay? You know, a little bit more from there, you can also find, say, like the midpoint here. So now calculate the midpoint between 5/2, -1, and 4 minus 4. Right? So, right, I mean, you've got this line here. Right, and now you're asked, well, you know, here's the middle between 1, 2 and 4, -4. How about the middle here? So 1/4 the distance from 4, -4 to 1, 2. Well, that point right there, right, you just take the sum of the x-coordinates, 4 plus 5/2 divided by 2, and then the sum of the y-coordinates, minus 4 minus 1 divided by 2. All right, so this one's got a little more arithmetic involved with it. So that point is going to be, so 8 halves plus 5 halves, so that's 13 fourths, and then this is minus 5 halves. Right, so 13 fourths minus 5 halves is going to be the coordinate of, this is going, of this point 1/4 of the way from 4, -4 to 1, 2. And so on and so forth. You can find even more points in between points. Cover that. I don't think so. All right. So again, we're just discussing some basic properties of the two-dimensional plane, and within the two-dimensional plane, midpoints are important, distances are important, and also sometimes areas are important. So let's talk a little bit about the area of triangles. So with triangles, the area is equal to 1/2 the length of the base times the length of the height. All right, so normally you just write A is 1/2 base times height. Now, what do we mean by base and what do we mean by height? Take two parallel lines like this, whose distance between them is h. So any triangle whose base is length b. So these lengths here are all b, 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 b. Now, if I had a right triangle, then the base would be b, and the height would be the length of the other leg, and the area would be 1/2 the base times the height. But any other triangle along whose third point is on that second parallel line also has height h. So all of these triangles have the same area. So for example, find the area of the triangle shown. So say this is point -3, -3. This is point 3 minus 1. And this is point 2, 2. and I want to find that area. Now, I need to know the length of the base, and I need to know the length of the height. Well, it's hard to measure those things, in some circumstances. But in the case that you have a right triangle, one of the angles is 90 degrees, then the base is the length of one side, and the height is the length of the perpendicular side. Okay, so if this is a right triangle, we'll be in business. We can calculate that area. So let's find these distances here. So we'll call this distance A, call this distance B, call this distance C. So distance A is equal to, well, the difference in the x coordinates squared. So that's 6 squared, right? 3 minus 3 is 6. Plus the difference in the y coordinates squared, minus 1 minus 3. Right, so that's minus 1 plus 3. It's 2 squared. So 36, that's square root 40. And length B, this is going to be difference in the x coordinates. 2 minus 3 is negative 1. And then difference in the y coordinates, 2 plus 1. All right, that's 3. So this one is square root 10. And C, 2 plus 3 is 5. And then 2 plus 3 is 5. So this is 25 plus 25, square root 50. So, right, a squared plus b squared equals c squared. So this is a right triangle. So the 90-degree angle is between the A and the B. So this is a 90-degree angle right there. Therefore, the base has length root 40 and the height has length root 10. So the area is equal 1/2 the length of the base, square root 40, times the length of the height, square root 10. Right, and remember exponentiation, right? This is 40 to the 1/2 and 10 to the 1/2. Exponentiation distributes over multiplication. So this is square root 400 over 2. Square root of 400 is 20, right, which is 10. So the area of that triangle is 10. And the only reason really we were able to calculate it in this case is because it turned out to be a right triangle. The only other instance in which it's sort of easy like this to calculate is if one side is horizontal or one side is vertical. If one side is horizontal, one side is vertical, then you can get the base and the height. And that's in the homework, and I'll let you guys get to that on your own, and we'll cover it tomorrow. Alrighty. So that's the material in section 1.1. Section 1.2 is a little bit quicker, a little bit less material. So circles and other graphs of equations. It's in the book. It's graphs of equations and circles, but here it's actually we're just going to be discussing circles. So a circle with center h comma k and radius r is the collection of all points of distance r from the center HK. So geometrically, that's what a circle is. So here's your center HK, and the distance from the center to any point on that circle, right, this distance is r, and that's called the radius of the circle. So by the distance formula, we therefore get that all points on the circle, all points xy, satisfy, well, the distance, which is r, is called the radius in this case, is equal to, well, that distance formula there, x minus h, difference in the x coordinates, plus y minus k squared, which is usually written like this. R squared equals x minus h squared plus y minus k squared. So this is the standard form. That's called the standard form for the circle centered at HK, standard form for the equation of the circle. Centered at HK with radius r. So r squared equals x minus h squared plus y minus k squared. That's the standard form. So, for example, find the standard form equation for the circle with 1. So first example, center 3, 1, and radius 2. Well, this is the h, this is the k. So this is x minus 3 squared plus y minus 1 squared equals 4. So there's your standard form equation. All right, center at, let's say, -1, 0, and radius 1. Center at -1, 0 with radius 1. So this is going to be x minus -1 squared plus y minus 0 squared equals 1 squared, which is 1. If we, you don't want to leave it like this. So instead we rewrite it more cleanly. All right, so that's the standard form equation for the circle whose center is at -1, 0, and radius 1. Right? So you can read off the HK. Here HK is 3, 1. Here HK is negative 1, 0. And the radius is just the square root of this number here. The circle with a diameter containing points 5, 1, and negative 1, 2. So I've got this, that's too big. So here's my circle, and I've got a diameter with these 2 points. Diameter is, twice the radius. So how would I find the center? Oh, let me make this a 1. How would I find the center? So I've got this diameter containing these 2 points. How do I get the center of the circle? I need to know the center, and I need to know the radius. Right? The 2 ingredients that I need to write down the standard form equation of the circle are the radius and the center. So how do I find the center if a diameter contains these 2 points here, 5, 1 and negative 1, 1? What's the center going to be?
Halfway between.
Yeah. How do we find that halfway point?
Wouldn't you use a formula and then divide the answer by 2?
What? Well, that would give me the radius. Yeah, the distance formula divided by 2. That'll give me the radius. But before we do that, so that's correct. But before we do that, let's find the center point. How do we find that center point? Right. Well, what were we talking about in the last section? What was one of the things we learned? We learned about somebody else was talking. Did you have a response?
Wouldn't it just be the y1 minus y2, the square root, and then the x1 minus x2?
Oh, that's distance again. Yeah, but of course that'll be the radius. But the center is going to be the midpoint of this diameter. Right? The center is the midpoint of this diameter. Alright, so the center is equal to, so you add the x coordinates, divide by 2, add the y coordinates, divide by 2, so this is 2, 1. So that's the center. And then the radius, well, is you take the distance from the endpoints in the diameter and divide by 2, or take the distance from 5, 1 to the center. So, whatever suits your mood. So 5 minus 1, that's 6 squared. 1 minus 1 is 0 squared. So the radius there is 6. Okay. So the equation of the circle is x minus 2 squared plus y minus 0 squared is the radius squared. So x minus 2 squared plus y squared is 36. All right. So, not 0, it's 1. So center is 2, 1, x coordinate 2, y coordinate 1. Radius is the square root of that, it's 36. And that's the standard form equation. Okay, how about this? Um, the circle with equation x minus 2 squared plus y plus 3 squared equals 16. What is the center and radius of this circle? Well, the center is what? And the radius, well, first of all, what's the radius? I guess that's the easier question. The radius is the square root of that is 4. How about the center? Well, the x-coordinate of the center is 2. What's the y-coordinate of the center? Not 3.
-3.
-3, right? This is x minus 2 squared, right? Y minus 3 squared. So this is 2 minus 3. All right, here's a nice algebraic trick. The following is an equation of a circle. Put it into standard form and then find its center and radius. Right. The point of putting it in a standard form is that you can read the center and the radius. So x squared minus 4x plus y squared plus 6y is equal to 3. Right. The standard form, right, is x minus h squared y minus k squared. Right, equals the radius. X minus h squared plus y minus k squared is radius squared. So the first step would be to do what is called completing the square. Completing the square. So that's something that we'll talk about a few times this semester. Well, at least twice. I don't remember if it's 3 times, but twice as far as I remember. At least twice. So group the x's together. So I've got my x's as, x squared minus 4x plus I got y squared minus 6y, and then I've got 3. So x squared minus 4x. Take that coefficient for x, divide it by 2. What do I get? Take the 4, divide by 2. What do I get? Follow along, guys. Take the 4, divide
2.
by 2. I get 2. Now square it. What do I get?
4.
4 again. So what I'm going to do is put that number here. Do the same thing here. Take the coefficient of the y. Divide by 6, divide by 2. You get 3. Now square it, and I get 9. add the 9 here. In order to keep the equation balanced, I got to add the 4 and the 9 to the other side as well. Alright, so here, 4 over 2 squared is 4. And over here, this is what we just did, 6 over 2 squared is 9. So I add in 4, and I add in 9. So 4 with the x's, 4 with the 9 with the 4 with the x's, 9 with the y's. And then you have to keep the equation balanced. So since I added 13 to this side, I got to add 13 to that side. Now this is x minus 2 squared. Hence, it's called completing the square. You put in what's missing, which makes it a perfect square. So x minus 2 squared, right, that's x minus 2 times x minus 2, right, which is x squared minus 4x plus 4. Same thing here. This becomes y minus 3 squared. Right, so the number here, let's do it in red. This is 4 over 2, and it's minus because that's a minus. Maybe I should make one of them. Oh, I did. I changed a minus to a plus, didn't I? That's bad. This is 4 over 2, and this right here is 6 over 2. This one is a minus because that's a minus. This one's a plus because that's a plus. Equals. Oops, I shouldn't have done it that way, shouldn't I? Equals. So it's 13 plus 3 is 16. Alright, so I've got x minus 2 squared plus y plus 3 squared equals 16. So the center, so that's the standard form. So the center, well, it's the same one that I did up here, actually. The center is 2, negative 3, and the radius is 4. So we took the equation for, a circle here. We put it into standard form by doing this thing called completing the square. And once you do that, then you can read off the center and radius. Let me show you another example of that. It stands repeating. So another example. So complete the square and find the center and radius for this circle. So x squared minus 2x plus y squared minus y equals 0. Okay, so take the coefficient of x, which is 2. Divide by 2, you get 1. Square the 1, you get 1. So add in, with the x's, 1. And then on the right, you're going to add 1. With the y's, take the coefficient of the y. Not the y squared, the y. What's the coefficient of the y? Disregarding the negative.
-1.
Yeah, just 1. Disregard the negative is just 1. Divide by 2. That's fine. And divide by 2, you get half. Square it, and you get what? A fourth. So add a fourth. Okay? So now this is x minus 1 squared. This is y minus a half squared, and this is 5/4. So the center is 1 comma 1/2, and the radius is root 5 over 4, which is square root 5 over square root 4, which is root 5 over 2, if you want to write it like that. Okay, so another example of completing the square. And we'll do this again later when we talk about solving quadratic equations rather than just linear equations, which we did in P8. Final thing in this section. So the points at which the circle x minus h squared plus y minus k squared equals r squared are found, the points at which the circle intercepts the x and y axes are found by substituting x equal to 0 and finding y, and by substituting y equal to 0 and finding x. So anyway, we'll do that tomorrow. Just one more little thing to do, and we'll take care of that then. Okay. All right, guys. So that's all for today. I'll be in my WebEx room at 11:30 if you want to meet with me there. If you want to meet with me but can't meet with me, then we can set a different time. But I'll send an email with a link for my WebEx room again. As I usually do every day after class. With my email after class, okay? And look at, watch for your corrected assignment coming up later today. Okay, guys, see you tomorrow.